law of indices. Okay, so this video is going to be about law of indices only. Okay, so we will go through the few law of indices and what you need to know to do well in this subtopic in this chapter. All right, so first of all, you must understand that law of indices has only a few laws to it. They look simple, but if you do not practice enough, if you do not learn to spot the patterns fast enough, you won't be able to spot it as quickly as possible in exams. So it's all about building that knowledge on how to spot things fast and get used to this type of questions. All right. So today, what I want you to do is just to understand what I'm trying to present to you. You must really understand every single step. Okay. And then don't forget, as I said, don't forget about the why method that I'm asking you. All right. I will keep teaching in a way. I will ask myself questions. Why this, why that, why this, why that, to improve your understanding and your focus. All right. And as I said, the mindset, don't forget about it. Okay, so first of all, the first law of indices that I'm going to teach you is actually the first one. Okay, you can see this: a to the power of m times a to the power of n equals to a to the power of m plus n. Okay. So when we look at this, right, we spot a few things. We spot that a repeated twice, and it's a multiplication. Okay, and then we spot that this is m, this is n. Right. So through this law, right, what it says that when you have two bases, okay, I come to the word bases first. Base is basically just a number that you write. Okay, this is called a base. And the power that exists above is known as the index or the power. All right, so you must know this is the base and the power is the index. That's why they call it indices. You will deal with a lot of powers. That's why you see powers everywhere. Can you see all these are powers? All right. Okay, so I move on. So it says that when you have two same bases, don't forget base is just a number. When you have two same bases, okay, if this is an A, this must be an A. And you are multiplying them with different powers or same powers. It doesn't matter, okay? The answer will result in the same base to the power of m plus n. All right? Will result in the power of a to the power of m plus n. Okay, the whole thing is in a bracket. The whole thing is the power of a. Okay? Similarly, if you want to break a to the power of m plus n up, you just work reverse the process. Okay? When you see there's the plus, means you can break it up to a to the power of m times a to the power of n. The way you can remember this is that when it's a multiplication, you add the powers. All right. When it's a division later, you minus the power. It's just the opposite. Okay. So for a new learner, right? If you are a new learner here, right? I hope that you can follow every single thing that I'm actually learning lah. It's very important for yourself to ask a question: why? Okay. So if I were to study this, right, I'll ask myself, why must it be the same base? Or why do they write m and n as different thing? Can m and n be the same thing? Basically, can I have a to the power of m times a to the power of m equals to a to the power of m plus m? Questions like this, you know, even though they sound stupid, right? Even though they sound irrelevant to what you're learning, but actually, right, it tends to help you focus, because when you ask a question, you're actually creating a question for your mind to answer. And when your mind is answering a question that you're questioning yourself, you tend to focus on that thing. You get what I mean? Because we tend to lose focus quite quickly. So this is a way to pull back my focus. Okay, so we learned that a to the power of m plus n is equals to a to the power of m plus a to the power of m plus n. Okay. All right. So the second one is just the opposite. It's nothing much to be said. A to the power of m divided by a to the power of n is equals to a to the power of m minus n. Okay. I give you example. Okay. Example is that when you have 3 to the power of 2 divided by 3 to the power of 3, just say, okay? So since it's a division and they are the same base, yeah, I always don't forget to mention it's the same base. If it is not the same base, you cannot do it, understand? Okay, so it's just 3 to the power of minus the power 2 minus 3. Okay, so equals to 3 to the power of negative 1. Okay, I'll teach you how to convert 3 to the power of -1 into 1 over 3 later. Later on, I'll teach you that. Right, this is the second law. This is the second one. More complicated questions I'll just go through later on. I've included different difficulties, different questions of difficulties. I mean, different questions, questions of different difficulties. Yeah, not enough sleep last night. So I'm having my coffee. All right, don't mind that. Okay, so that is a to the power of m. This is the first two laws basically. Right, next on we move on to the third law, which is a to the power of m in a bracket, you power one more time. Okay, a power of a base, you power the whole thing one more time. Remember the format of it. Okay, remember the format of it. It's just when you have power and power side by side, you just remember you multiply the power. Okay, if you have power side by side, you multiply the power. Okay, so I want you to see something. For example, if I give you 8 to the power of 2 times to the power of half. Okay, you see, both are powers. Okay, I did not multiply by half. I power and I power again. Okay, basically, recognize it, 2 powers next to each other or 2 index next to each other. What you do is you multiply them. 2 times 1 over 2. Okay, 2 times 1 over 2 I can write in the form of brackets as well. Okay, I'm not sure what level you are, so I try to make it as simple as possible. So even though you are like, maybe you are a Form 2 now, and you would like to learn, oh, I want to learn what is Form 4 Add Maths all about. They sound very fun. Then that's what you can do. So it's 8 to the power of 2 times 1 over 2 is, okay, so 8 to anything to the power of 1 would be itself. It will be 8, right? So it's important, you see, steps like this are very important, but you must also understand. You see, when I'm teaching you, right, because I'm giving you the answer, so it's easy for you to understand what I'm saying. But is it the same when you're doing it? That's the thing you must really implement to yourself. You must ask yourself, you are going to do the paper, not me. So it's not just about you understanding my lesson, it's that whether you can create the same thing I create right now. And that is important, all right? Okay, so actually that's the reason why, right, I actually created this called the section for you to write extra notes on the right. Can you see the blank space here? This is a section if you want to use these notes as your sample. You can actually take it, include the PDF into the below the channel. So what you can write the notes here. Okay, for example, never be ashamed of writing simple things down, because everyone learn from a foundation. Okay, so it doesn't matter if you do not know anything to the power of 1. Anything to the power of 1 is equals to that thing itself. Or simple things like actually a simple number like 8. Any number is actually 8 over 1. I can write it as 8 over 1. Okay, you might see this is very simple things, these are very simple things, but until you actually meet a complex problem that requires simple tricks like this, you realize how important these are. Okay, I know that some of you know this, but can you spot this when things get complicated? That is different story. Okay, because maths is not about difficult questions, it's about how you spot the patterns and how you recognize them. Right, it's like vaccine. You see vaccine entering your body, you got to recognize it. So next time when the real disease comes, like the COVID-19, you can actually you know what to do with it. Okay, so it's about that process. Okay, not doing something without planning, just writing stuff down. Right, I hope these are useful to you. Okay, in fact, I think these are more useful to you than actually me teaching you. All right, if you know these lessons in studies, in life, you would automatically know the steps and know what it takes for you to do well. All right, sorry, I'm a bit talkative. You got to mind me that, because I really want all of you to do well if possible. All right, so this is a wanted section. I call it the wanted section. Where you can actually include your stuff. I learned this from a lecturer myself, from a teacher, from a teacher of mine last time. Okay, he's a very, very great teacher that I'll talk more next time. So I move on with the fourth law of indices, which is AB to the power of n. Okay, now you have two items in a bracket multiplying each other. Don't forget, you see simple stuff like this, I repeat again. When you have A, B, C, D, E, F, what is this? Okay, you must know they are different. Okay, there are different alphabets here. You might tell me that. But you must know the operation between them is actually multiplication. Don't forget. Okay, when you see alphabets next to each other, see, or zxy squared cubed 2, they are actually multiplying each other. Basically, it means z squared times x cubed times y squared. Okay, I try to make it as simple as possible, to break it down as simple as possible, so a person who wishes to learn, not in Form 4, can learn it well. Okay. All right. So I try to make this course as complete as possible, as open and as free as possible for all of you. All right. So that I hope that everyone has a chance to get free education lah, and quality education. I hope I'm providing a quality education. I'm still learning, okay, because I'm just starting up online presenting in YouTube. So any feedback, just let me know. So you know a to the power of a times b. Okay, so as I said just now, a times b to the power of n, when you have two things multiplying each other to the power of something. Okay, when you have two things multiplying each other in a bracket, two or more things, it can be a number of things in a bracket multiplying by to the power of something. Okay, that's the meaning of this. You have few things in a bracket multiplying each other to the power of something. What you get is the individual item to the power of that thing outside, which is a to the power of n times b to the power of n. Okay, so you might ask me, oh, what is this? How do I spot this? What is this? What can I say about this? Okay, this is actually, as I said, when you have like alphabets sticking to each other, right? This is basically a to the power of n times b to the power of n. Okay, when you have variables, when you have unknowns sticking to each other, they are basically multiplying each other. All right. So if let's just say you have a b c squared to the power of 2, what do you get? Okay, what do you get is you have three different items multiplying each other, a b c squared. These are the three things. So what you get is basically a squared times b squared times c squared. This is the c squared, and then I square it because of this one. Okay, so what you get is a squared, b squared, and this one. Look at law number 3, law of indices number 3. When you have two powers side by side, what you get is just a multiplication of the power, which is c to the power of 4. All right, so this is basically what you will get as your answer. Okay, so it's very important for you to try out as many questions as possible before you actually move on to the questions of your real exam paper, because your exam will tend to expect that you are really good in this and you're really fluent in this, that you can solve more complex problems instead of worrying how to solve this kind of simple problems. Okay, these are very simple in this chapter, but I try to make the simple stuff even simpler. You get it? Okay, learning things is all about breaking things down. I will slowly introduce tips and lessons to you all. All right, or maybe you make a new video about it if there is a demand. Learning is all about breaking things down. All right, and seeing them individually and them. Yeah, it's basically that's it. It works for maths as well. Okay, but it all starts from the mindset, which I'll cover in another video lah. I don't want to take too much time up. So you have this answer. All right, so I will just erase. If you want, you can just have a note and follow along. Lastly, if you have similarly, now you have a divided by b to the power of n. Just now we had something multiplying each other in a bracket. Now we have something dividing something in a bracket. So it's the same thing. For law number 4, just now we had things multiplying in a bracket. You just write it as it is. Basically, the power comes here, the power comes here. All right. You just take individual item to the power, a to the power of n times b to the power of n. So this one is the same thing, but this division. But the concept is same. What you do is a to the power of n divided by b to the power of n. Basically, the power of n, right, you just throw it into the power. You get what I mean? All right, when you have something to the power of n, when you have maybe a, b, c, d over e, f, g, okay, to the power of n, let's just say, is equals to, let's just see, you just throw things in, okay, you just throw in. And don't forget, you don't write this, okay, you don't do this, a, b, c, d to the power of n divided by e, f, g to the power of n. It's not correct. This is not correct, okay? Because why? Why is it not correct? There's always a reason. Why is it not correct? Okay, because I've learned when you have whenever you have situation like this, something something multiplying or dividing to the power of n outside, to the power of something outside, you got to multiply this power to the individual items, to individual unknowns inside, or individual numbers inside. What you do is, a is one item, a to the power of n, b to the power of n, c to the power of n, d to the power of n. Basically, you have the power into everything, provided it's multiplication. You must always be sensitive with the words I use, because every time before I teach, I know what are the mistakes that students tend to make. That's why I tend to emphasize on a certain word. I keep on repeating multiplication and division only. If you have a plus b to the power of n, it's a totally different story. Okay? Because it's plus inside. Okay, I repeat again. You have a plus b plus, it's a different story. Only apply what you know is true. Do not simply create your own theory. Okay, have a solid foundation, then build your foundation by applying by applying it, and not just simply assuming theories. I think it's like that. That's why I'm following it. No, never do that, right? And then e to the power of n, g to the power of n. Why can I do it? Because it's multiplication and division in action. This is multiplication, multiplication, multiplication. E is multiplying f, f is multiplying g. And the whole thing is dividing E, F, G. Okay, then we can do it. All right. All right. So for the last question is about a divided by b to the power of n. Hey, wait, I just covered that. Oh my god, that's funny. All right. With that, right, I want to introduce a way for you to do practice on this. Okay, if you are somebody today who is not very familiar with this kind of stuff, right? With this is totally new to you. This is your first time learning it, and I hope you're learning it from the right person. All right. Then what I want you to do is actually, right, I want you to think, what are the characteristics? I want you to list out all the characteristics whereby you can apply these indices. You get me? For example, I give you one very good example. 2 to the power of 3 times 3 to the power of 3. Okay, if you are a person who knows, if you are a person who knows this law of indices, right? You wouldn't make a mistake of doing this. You wouldn't do this. What mistakes normally students tend to make? They would think, a to the power of, or they would think, if you have they remember very roughly on the law of indices, they said something like, if you have same something, then you just add up something. So they think, I've same something, then I add up 2 plus 3 to the power of 3 or something like that. I do not know. All right. This is the kind of student that does not have a solid foundation, does not have clarity in his mind. Everything you learn in math must be clear in your mind, that you are able to visualize everything out, to check whether you're good at it or not. Okay. So in fact, this is actually a very common mistake that people tend to make. Okay, I'll just write it down at the side. You want to write, you can write it down. I've included many things for you. 8 is actually 8 over 1. Then what did I say just now? I forgot about that. 8 is equals to 8 over 1. What did I say just now? I don't remember. Okay, but never mind. I'll slowly add on here. You add on to yourself, to yourself. Anything that you don't understand, that it's a new thing to you, don't feel frustrated. Don't feel, I'm so stupid not to know this, even though it's so simple. Everyone is walking up a ladder. It's about how early you realize you have to walk that ladder to achieve certain things. All right. So you have to walk step by step. Sometimes maybe you have advantage in a certain manner, you can walk double step. But there's no way you can fly from step 1 to step 40. What I mean. So think of it as a ladder. You have to walk it step by step. Everyone is walking the same ladder. The more effort you put in, the better, the smoother you will walk the ladder. All right, you walk the ladder consistently and nothing will go wrong for you and your subject. And then one more thing I want to tell you is, this is a special thing. When you have a to the power of n times b to the power of n, spot the difference between this one, this a to the power of n and times b to the power of n, and this one. What is the difference? One, on the left, this one is same base, different power. Okay, my writing, sorry, just don't mind because I want to do it fast. This one is different base, but same power. So you must have clarity in your mind. You must be able to differentiate. Okay, I'm very organized. I know that for this one that I learned law of indices, the bases are the same and they are multiplying each other. And then you just add the power of the answer would be just the same base to the power of the summation of the individual powers. Okay, for example, a to the power of m times a to the power of n is equals to a, same base, to the power of m plus n. Yeah, so that's how you clarify things with yourself. This is a very simple thing, but I'm using this technique. The motive is what I'm trying to deliver to you is not that, oh, this method must be used to learn this topic. No, I'm trying to tell you to cultivate this habit so that next time when you learn things that are more complicated, right, you have a systematic way to organize things. Okay, the first moment you learn it, never ever, the number one rule to learning things is never ever confuse yourself. Never ever let something go with yourself being confused for the thing. You can maybe after learning something, right, you do not understand, that doesn't matter, but you cannot leave yourself to be confused. Not understanding something is not necessarily the same as not confusing yourself, as confusing yourself. Okay, so the purpose of me saying this is just for you to not confuse yourself. All right. Minute. Okay. All right. So where was I? Okay. So I'm clear with myself that A, as I said, same base, different power, same power, different bases. So what do you do when you have same power but different bases? Okay, for example, you have 2 to the power of 3 times 3 to the power of 3, like this example. I'll just put it at the side. What do you do about it? What do you do about it? All right, what do you do about it is that, okay, remember, power is like bringing you to a world. If you are in the same power world, you can multiply them. You can multiply them 2 times 3 to the power of 3. It's just like this. It's just this. The way I used to tell my students and I used to tell myself is, power is like a world. Okay, it's like a world. As long as you're in the same world, you can multiply the stuff in the world. For example, if I have a plus b to the power of half, times, must be times again, okay? I emphasize on this again, must be times. A plus b to the power of half times b squared c squared to the power of half. Can I multiply these two things together? Can I multiply these two things together? You can, okay? So, because on what basis, on what theorem, on what proof can I do this? Is that when you have something to the power of n times a different base to the power of same power. The idea is same power. It doesn't matter what A is. It doesn't matter what B is. You can just simplify it to be A times B to the power of n. Okay, so what I can do is A plus B to the times B squared C squared in a bracket to the power of n, which is your half. Okay, this multiplication. You might be asking me, okay, I try to explain every single thing so that you can really understand, okay? So you might be asking me, why you said just now, it must be multiplication and division. But there's a plus here. Okay, always when you encounter questions like this, right, you must be clear on what theorem, on what law are you applying this thing. I'm applying this based on this law. A times B, A to the power of n times B to the power of n. And A can be anything, B can be anything. So A can be A plus B. Because A can be anything, as long as this whole thing powers this thing, powers n. This whole thing powers n. You get what I mean? I'm not sure whether you get what I mean or not, but I'll try to repeat it. All right. I'll repeat again. It's a bit messy now. Okay. I'll repeat the same thing again. As I said, everything that I'm mentioning here is very important. Unless you are super genius that you don't need that you are so advanced that you're just looking forward to solve only difficult questions. Then you can just skip the video to the end. But if you are really learning maths, you want to learn maths properly, I'm going to explain every single thing that you want to know, that you need to know. Okay, if I can spot the things I want to explain, right? So just saying just now, okay, on you're basing this. Okay, A plus B plus C to the power of 3 times BCA plus AB to the power of 3. Can I multiply them? Okay, think of the theorem that you know. Is this part of law of indices? No. Okay, this is not part of law of indices. Okay, it might be related, but it's not directly part of law of indices. Okay, then what is this based on? Oh, I know that when you have same power rule, I call it the same power rule just for the simple sake. All right. So the same power rule states that when you have A to the power of n, same power times B to the power of n. I don't care what is A, I don't care what is B. As long as they have the same power, what do I do to them is that I multiply them. Okay, because they're in the same world. So I can just multiply them and power to the same world. And that is actually why, if you actually think things simple, if you think about simple things complex, in a complex manner, right, you realize, right, 2 times 3, why can I multiply them? Why can I multiply 2 by 3? Because it becomes 6. It's actually 2 is actually 2 to the power of 1 and 3 to the power of 1. That is why when you have in the same world, you will produce 2 times 3 to the power of same world, which is equals to 2 times 3 inside is 6 to the power of 1, which is also 6. You get what I mean? So if you want to think about simple things in a harder way, for better explanation to yourself, you can think of this. All right. So coming back to this, what can I do about them? Can I do anything about them? Yes, of course. Why? Because this is something to the power of n times something to the power of the same n. Okay, this 3 and 3 is same. So I just multiply these two things together. And when you take these two things together, right, you must take the whole thing. Whole thing, again, go back to your theorem. Anything that you don't understand, go back to your theorem. Because your theorem said that A to the power of n. You get what I mean? A to the power of n means they assume that you take the whole A. Anything that is in the power, you take it. Anything that is in the power of B, you take it. You multiply them. So anything that's in the power is A plus B plus C. A plus B plus C multiply with anything in the power BCA plus AB. And then in a whole bracket to the power of 3. Okay, this is workable. All right, this is just a trick that I'm telling you, even though it's not part of this, it's related. Okay, it's closely related. All right, so after this, we will move on to, I'll just write the stuff here, okay? You can write your own notes. Just pause the video and write your own notes, all right? This is just 6 to the power of 3 to complete it. All right, these are just basically all the law of indices that you need to know. But people tend to make simple mistakes, as what I've mentioned just now. One of them is when you have the same power but different bases, they will confuse it with this first law, which is same base, different power. Okay. So you see, I keep on emphasizing how you must organize your knowledge nicely. You must organize, okay, this is same base, different powers, and it's multiplication between them. The other one is multiplication between them as well, but it's same power, different bases. So you must get this in your head before you can actually move on to do complex questions. Okay, so there are some special indices stuff that you need to know, okay, in this chapter. Not only in this chapter, in algebraic mathematics algebra. Okay, when you're doing algebra or even other things, okay, when you're going further next time, everywhere you use this stuff. So you must make sure that you actually build a foundation right now. I don't care whether you're Form 2 wishing to learn higher degree stuff, or you're actually Form 4 currently in par with the syllabus, you're learning something like this in school, or whether you're Form 5 having exam this year and you still do not know what are you learning, what you were learning in your Form 4. So I hope that after you've completed this video, right, there's no need for you to actually revise on the theory. Okay, I want you to have a goal whereby you actually follow my lesson so closely that you can actually recall and visualize everything right after the class. Yeah, that is what I want you to do. That's a goal for my class. Okay, once you've gone through everything, I want you to take maybe like 5 minutes, try to not to memorize, I want you to try to understand. Okay, there are 5, don't forget, there are 5 of them, 5 law of indices. You must know, you must be well versed of all of them, and tricks like this also you must know them. Okay, so number 2, you must know a few other stuff about indices. One of them is that when you have something to the power of 0, it will give you 1 automatically. Okay, don't forget, when you have a 0 power, it gives you 1, except 0 to the power of 0. This is the only thing that doesn't give you 1. Okay, everything else gives you 1. You might want to ask why. I won't explain it here, but it's good for you to ask why, so that you can remember that it helps you to focus better, and it can actually help you to create a connectivity between your neurons. Because when you ask a question, as I said many times, it actually creates a question for you to answer, and that creates a neuron connection. Okay, that's what I believe lah. That works for me. So you must know A can 0 to the power of 0 is not equals to 1. Other than that, anything to the power of 0, 2 to the power of 0 is equals to 1. 20 to the power of 0 is equals to 1. 20.112 is equals to the power of 0 is equals to 1. 20.112 over 2.1102 is equals to the power of 0, the whole thing equals to 1. Okay, as I said, when you see, this is another thing that people are struggling with. They know that A to the power of 0 is equals to 1, but when they see something inside the bracket like this, right, they say, oh, got division lah, can I still apply to the power of 0? Can you do it? Okay, so don't forget, whenever you have a bracket, something like this, right, you must understand, you go back to the theory. It is A to the power of 0, means A can be anything. Okay, A can be anything as long as this A is next to the 0 power. All right, so A is anything as long as next to 0 power. So this is actually next to 0 power, so this can be done. You understand? It can straight away apply it. What is apply it? For example, if I have 2 times 3 to the power of 0, can you straight away write 1? Cannot. Why? Because the theory, go back to the theory that you learn, the foundation that you learn, always refer back and work things out from there. Why? Because you learn that A to the power of 0 is equals to 1. It's the thing that is next to the power that is going to turn to 1. You get me? The thing that is next to the power. So only this thing will become 1. Okay, so this is actually not equals to 1. In fact, this is actually 2 times 1, which is equals to 2. Where did this 1 come from? It came from this 3 to the power of 0. Why is it 3 to the power of 0 is equals to 1? Because I have a power to 0, and I have a number or an unknown that is right next to this power. Okay, this power belongs to 3. It does not belong to 2. You get what I mean? Okay, another word I'll use is it belongs. The power belongs to who? Okay, for example, for this question, the power of 0, this is not degrees, this power of 0, hope you're following my lesson. This power of 0 belongs to 20. Similarly, if I have a fraction a over b to the power of 0, this 0 belongs to this whole thing. You get what I mean? Because this bracket is here. If the bracket is not there, then this is only belongs to the A. But the bracket is there. Bracket has priority every single time. So don't forget, bracket has priority every single time. So when you have the bracket, it means that this 0 is also the power for the whole thing, not necessary for A or B only. Okay? Or you want to look at it in another way, actually, right? You can think of it as law of indices number this one. Okay, you must understand when you have division of something, power of something is just A to the power of 0 divided by B to the power of 0, as I mentioned. Division to the power of something. If you have something division to the power of something, it gives you this. What is the law that supports this? Is this thing. Okay, always go back to the law. All right. So A to the power of 0, which will give you the same answer. Okay. Okay, it will give you the same answer. If you want to apply straight away, you want to apply, this one will give you 1. This one will also give you 1 over 1, which is equals to 1. So you see the answer will be the same. Okay, but this is not so important. I'm just trying to make things as simple as possible. I want to rub everything first. Wait a minute here. I don't want to touch the line. That's why I got to do this. It's quite troublesome. Okay. All right. So and the next one that I want to teach you on is actually this part. All right. When you have something to the power of negative something, okay, see, is something to the power of negative something. So what does this mean is that I know that I can predict whatever questions that come out already. This one, this A can exist in a bracket. They can give you anything. Even this N can give you in a bracket, can be anything. You get what I mean? So I'll show you what I mean. So but I explain to you what is the theory first. When you have A to the power of negative N, you will become A to the power of N. 1 over A to the power of N. Basically, what does this negative power do, right? Negative power actually shifts the power to the denominator. Negative actually shifts the power to denominator. For example, if I have A to the power of negative 7, okay, negative, you can think of it as you bring it downwards. You have 1 over A to the power of 7 right now. Okay, you shift it to denominator. Denominator is the one below here, the fraction, below the fraction. All right. Okay, what if you have 1 over A to the power of 2? Just say, okay, look at it individually. Oh, sorry, I made the wrong question. A to the power of negative 2. What if you have questions like this? Think of it individually. What do you know is A to the power of negative N? So you solve from this one first. You don't get confused when you see 1 over straight away. Okay? What you do is you look from this thing. A to the power of 1 over 2, I know from the theory, right? It's going to give me, what is it going to give you? It's going to give you 1 over A to the power of 2. Okay? This negative is something like 1 over. Okay? This negative is something like 1 over. You can think of it. This negative is something like 1 over. All right? So what you will get is that you will get this 1 over, I will write back 1 over, and then this one has become 1 over A squared. Because as you know, right, this one has become this one. So I just put it inside here. This 1 over is the same thing. Okay? I hope you're following. All right? So then only you solve this one slowly. Solve step by step, always in maths. So what you'll get is just when you have a fraction. Okay, this is another problem that maybe some of you are facing. When A over B over C, what will happen is that think of it slowly. It's something like A divided by B over C. Okay, A divided by B over C, and you know from primary school that when you divide a fraction, you just tilt the fraction over. You just turn it to times A times C over B. You see, what I did was I changed divide to times, and I just switched the position. I just invert the position of B and C, of the fraction basically. So I just get AC over B. This is my final answer. Okay, this is what you can think of it when you're dividing a fraction. Okay, this is about dividing a fraction. So this is something that I would, if I were you and I do not know this, I will straight write down in my 1/3 section here. Okay, this section, basically this section is called the 1/3 section. I'll just basically write it here. so that my future self will never ever forget this mistake that I'm making now. Okay, the fact that I do not know what to do when I look at this right now must ensure that my future self will not repeat the same mistake. And this is actually a very important principle that I would cover in maybe one of my productivity videos. All right. So I'm done with that already. So don't forget lah, 1 over basically, basically when you have a power of a negative number, when you go for the power of a negative number, the negative will change to 1 over. You can think of it, it will change to 1 over a to the power of n. Okay, and I repeat, it will become a to the power of n, it won't become a to the power of negative n, okay? This is something you want to take note, the negative will disappear. Okay, basically this negative change to 1 over. So the negative disappear down here. All right, this is something I want you to note because a lot of people make mistake. Oh, when I say negative change to 1 over, they think, oh, okay, equals to 1 over a to the power of negative n. They copy everything, which is wrong. All right. Yeah, so that's all I want to tell you about this. Then the next theory that I want to teach you on is this one, which is quite important also. All right. When you have a to the power of fraction, a fraction is basically anything can be a fraction. P over Q. They use P over Q. Okay. I wrote in the notes P over Q is just basically remember the name for it. There's a name, okay, that I call actually power root. Okay, this is taught to me by my teacher last time. Power root. Remember the name power root. Tell yourself power root, power root, power root. All right. Okay. So you see, questions like this, right? You can ask yourself also. You can ask yourself stupid questions. Ask yourself stupid questions so that you can remember better. Ask yourself stupid questions. Trust me. Ask yourself why power comes from not root comes first. Why does power come first, not root? You might not have the answer. It doesn't matter. This is a irrelevant, illogical question. But the fact that you ask the question actually improves your focus. Oh, at least next time you remember. I remember me asking myself before this, why power came first. So now I know actually power comes first before root. Because right, some people might remember it and then power root, power root, power root, and they don't study, suddenly it becomes root, power, root, power, root, power. Then they think that the top one is root. So remember power comes first. What does it mean by power? Power basically means you power it. The index is P. Okay? And root means what? Means you take the Qth root. Okay? If Q is 2, means you take the square root of a to the power of P. Okay? This is very simple, but you must be able to work it out. Okay? So what I want you to do is try to understand why I write these two formats. Try to spot what's the difference between these two formats. Can you spot it? I hope you can spot it. One is, okay, how do you analyze this thing? How do you analyze this thing? This thing looks simple. Or maybe it looks complex to some of you, but how do you analyze it? That's the most important thing. What is this? I'm trying to explain this in words is when you take a to the power of P, that's the first thing you do. You take a to the power of P first, then what you do, you take the Qth root of this thing. Okay, so first thing is I do a to the power of P, then only I take the root of Q. You take the root to the Qth root of this thing inside. So first step is you calculate inside, then only you root it. But for this, since I told you bracket has priority, in any case, when you have bracket, you have priority. So what you do is you got to solve what is inside the bracket first. What is inside the bracket, you must solve first. Okay, so when you solve what is inside the bracket, you realize that you got to take the root first, the Qth root of A, calculate the value, then only you power P. Okay, so the difference is in the sequence. This one you power first, then you root it. This one is you root it first, then you power it. And the fact that I'm writing it here is that to tell you this thing can actually be this or this. It doesn't matter. It's the same thing. To prove it to you is actually very simple. If you have, let's say, 64 to the power of 64 to the power of 1 over 6. What is 64 to the power of 1 over 6? Okay, so you know from the acronym, you know that this is power, this is root, All right, power root, don't forget power comes first. You see, it's better for you to remember right now. You can remember better. Oh, actually power comes first. Why? Because I memorized just now. I asked myself a question, why power came first? So ask yourself stupid questions. Okay, ask yourself stupid questions. I can even ask myself, why is it 1/6? Why did the examiner give me 1/6? Not 1/7. Yeah, questions like this you can keep asking yourself. You might not have the answer, but it doesn't matter. The purpose is not for you to answer the question, the question that you are questioning is to improve your focus. All right, so 64, I can either write it, you power first, then you take the 6th root, or what you do is you take the 6th root first, then you power 1. Okay, so this one, you just type in a calculator. I hope you know how to type in your calculator. Basically, what this means, right? Actually, basically, what this means, if you don't understand, right? If you are someone who don't understand yet, is basically, right? 6, the power 6 here means what? Means what times what times what times what times what times what? Basically, you time 6 times, and these 6 things must be the same things. Okay, equals to 64. Okay, what times what? They must be same thing. Okay, x times x times x times x times x times x times x must be gives you 64. What is x? This is the meaning of root. All right, so this is for a person, maybe you do not know what it means. Okay, because you are used to seeing square root, you can use the calculator. Square root of 4 is equals to 2, or in better sense is plus minus 2. Okay, this is very important. I'll explain to you next time in other topic videos. All right, so like for example, what is the cube root of 7? You type in calculator, you should get 3, because I know 3 times 3 times 3. I times 3 times will give me 27. So if I work backwards, I find what is the cube root of 27. It gives me 3. The answer is 3. I don't know whether you get me or not. All right. So you take the 6th root, right? So what you check about it. So how do you type in calculator is that you type 6, then you type, I'm using the Casio 570 MS. Okay, Casio 570 MS, but it works, I think, for every single calculator, of course. It's just whether the buttons are same or not. So what you do is 6, then you press shift, and then you see this button. For Casio is this. For Casio 570 MS is this. 6, shift this one, you'll get it. So then you write whatever value you want to root it. Then you write 64. All right, then you get the answer, which is 2. Basically, what this means, right, is that you are taking the 6th root of 64, which is 2. So what it means, right? Okay, I want to explain what does this mean. This means that 2 times 2 times 2 times 2 times 2 times 2 gives you 64. You times 2 6 times. What? Okay, so if you have if you see, right, a number like this, maybe 7 of n, what does this mean? You must be able to explain to yourself. Okay, what does this mean is that what is the number that you need to multiply by itself 7 times? A number that you have to multiply by itself 7 times to get n. Okay, this is the explanation I want you to tell yourself, drill in your brain, all right, to get to know these things instead of just knowing square roots and cube roots. You must be able to explain to yourself. Okay, so this is basically all of the theory questions that I've included in these notes, and it's really very sufficient already as compared to maybe what you learn from your reference book or whatever it is, because I've included a lot of maybe simple or complicated, confusing, common mistakes. I've included many of them, which I expect you to write in this wanted section lah. I did not write it nicely, but I'm expecting you to write it down. Why am I writing it down? There's a reason for everything that you're doing, all right? Why am I writing it down? To prevent my future self from repeating the same mistake. It's okay to make mistake. In fact, if you do not make mistake, I don't count you as a successful person. I don't count you as, I don't believe that you can be successful without making mistakes, in other words. All right, so it's all right to make mistakes, but it's really not all right, and it feels terrible. It is terrible. It does not only feel terrible, it's terrible in nature that you repeat the mistake in your future. So learn to not repeat your mistake instead of avoiding yourself to repeat to make the mistake. You get what I mean? So focus on not repeating the mistake. And how can you not repeat the mistake is to have organized notes, organized system of writing your place where you can access it easily. When I write it at the right hand side, or maybe with different colors, I can look at it one shot, look at it in one go. I know that this kind of stuff I can write it here. Or what I recommend students to do is that you can actually create another folder. If you're using book, you can get a book or maybe get a few test pads and write down. These test pads are only specially made for questions or maybe silly mistakes that I usually make. Only silly mistakes. Yeah, only silly mistakes that you're going to put in. So as you write down and you progress, maybe after 3 months, you have compiled like 5 pages of silly mistakes. So before exam, right, once you just go through the silly mistakes, right, it's proven, in fact, actually, once you've gone through it, you can go through it immediately and within a short period of time. You don't need to find, oh, what's the silly mistakes that I used to make? You won't even think of that. All right, because if you have a complete list of your silly mistakes, it's so easily accessible. You know straight away when you look at it in a single piece of paper that is so simple and that is so easy. You won't get how easy it is until you actually do it. Then you realize, oh, I'm not making the silly mistakes as I'm writing in this paper, and that is very good.